Hi, and we're looking at this Elliott Sound Products preamplifier again. I'm going to investigate what's going on with the master volume control there. It's not working as I think it should. So I'm going to put this back on some test instruments and see what we get out of it. Greetings, the Astro 30 here yet again, and I'm looking at this Elliott Sound Products preamplifier for guitar. The master volume control is a very touchy, like right down at the very end of its travel counterclockwise you can actually hear distortion coming through from the other high gain stages. Then when it's rotated slightly up, that distortion goes away. It never reaches absolute zero, and then when you turn up a little bit further it's almost like it's full on. There's no variance there as there should be. So I reckon there's a wiring issue here, mainly the ground. Now when reading the original article, and I'll show the schematic in a minute for the 15th time, that all grounds should be taken from the same point, not different points on the board. I've got the ground for the volume coming off of over here, and the ground for the rest of the circuit up here, and then there's an input ground over here, but I don't think the input ground would matter so much. It's mainly these two grounds. So I might lift that ground and add another wire back to where the potentiometers are grounded. So this is the schematic again. Now there's one ground point here which goes through all of the controls. So he's telling you to take the ground point off of the ground point of the control wiring, which is this one, including the master volume's ground, which currently it is not. It is going up to a ground further along the circuit. So first I'll put it on some test instruments and see what it's doing on the scope before I start busting out the soldering iron and modifying some wiring. Okay, I've got the thing hooked up to the oscilloscope and turned on. Got the generator sitting at roughly 500 millivolt, and as we can see on the scope, with the master volume control all the way down, the gain control's only up about probably a quarter. We've got visible distortion on the screen at roughly 0.04 volts. No frequency, and the duty cycle around 70%. Now as I gently rotate the control, master control, we can see that distortion buggers off. There's a bit of noise, but it's because I'm touching the control, it's not grounded. And all of a sudden it shoots up to 0.24 volt. So 240 millivolts already coming out. The waveform's not exactly sinusoidal either, but then again it could be this generator. And then when I get to a certain point, the volume starts increasing there. So I'll turn the sensitivity down. See, not much happens around most of the control's rotation till about halfway, and then it starts shooting up to 1.2 odd volt. So that control is not working anywhere near as it should. So that's kind of annoying. That's on the minimum range setting. Distortion, 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 and then suddenly the signal's there. So that is not functioning anywhere near how it should, and I do not like the way that these switches work on this thing because of the way the case is. And with the generator connected directly to the oscilloscope, we can see the waveform is perfectly sinusoidal. There's no issue with the sine wave, so it's whatever the circuit is doing to the signal that's making it do that. So what do I think's going on with it? Well, I think it's most likely the grounding, as I said. So that's the first thing I can try moving the ground of this control to the ground of these controls and see if that distortion goes away. If it does, it'll be happy days. If it doesn't, well, the only other option I've got is to try changing the pot to a different one. That's all I've got, but I reckon it's grounding, and this is why you should always use one grounding point, including a star grounding point for things, because this is what happens. You end up with earth loops, and you can be scratching your head trying to figure out where it came from, what's causing it, and how to fix it. At least it's not an earth hum loop at this stage. I really don't like having to do things twice, but it is what it is. Not that I can actually see what I'm doing. Oh great, got the shakes again today. Let's try that again to where I can see it. So somehow now I've got to get that in this concoction of wires. Might have to remove that cable tie. Now put another one on there. I really do not like having to do things twice because it's annoying. I can always put another cable tie there, that's fine. Just get those wires out of the way so I can get in there with the soldering iron. If this works, I'll make it permanent. The wire's probably a bit long anyway. Okay, so that should be ready now for testing. Alright, so I've got the stuff all hooked back up again. The master control is now at 0. I'm going to plug it in again. And that's interesting. Now we've got different distortion. And I have no idea where that one is coming from. Just around the back of the pot there. Doesn't seem to make any difference. Well, that's kind of frustrating and annoying at the same time. I seriously do not know what's going on here. So I'll switch gain positions. It doesn't make any difference. Yeah, there's something seriously not right here with the circuit. I don't know what exactly it is, but yeah, it's not operating as it should, and it's quite annoying at this point. Okay, I've got the other 50k pot soldered in now just to test, and I've got the same result. So the distortion is less when I use that ground wire instead of the mid-range pot's wire. So I really don't know at this point what is occurring here. Could move the ground of my test instrument to the input ground rather than the 0 volt. Makes no difference. Still got that distortion there, and the pot doesn't work as well as it should. Well, alright, I'll wire this back together as it should be, and yeah, we'll have a discussion. Alright, so I'm back to the original setup with the original way it was wired and the original pot, and we're back to exactly how it was before. Seems to be an earth issue here. Don't know if it's an earth issue or just leakage current at this point. But yeah, that's, as an amplifier, that is going to annoy the piss out of me no end when I'm using it. Okay, it's actually a few days later now, actually more like a week later. I'm not going to let this get me down because, you know me, I like to try and solve a problem. So here are my intentions of how I plan to address the finicky, touchy master volume control. First off, I'm going to change these two op amps to what the original circuit was designed with, which was TLO72s or LF353s, whichever you want. And I've got them here. And basically I was reading the data sheets between the NE5532 and the TLO72. There is quite a few differences. One, it's a bipolar junction transistor input stage, which shouldn't make that much difference. But two, it's actually got a fairly high input impedance. We're looking at around about 300k here. The TLO72s are a junction field effect transistor input stage, or JFET, which shouldn't make a difference. But its input impedance is only 10 kilo ohm. That is a fairly big difference right there, so I might want to consider changing those first and see if it makes a difference. Hopefully it does. So that'll be the first change, and the second change I'm going to try is changing these two 100 nanofarad MKT capacitors for what the circuit actually called for, which was 100 nanofarad ceramic type. I believe these are 100 nanofarads. I'll have to investigate that in a second. I didn't actually look before I bought them. And finally, the change I'm going to do anyway is I'm going to reduce the gain on the second amplifier stage, as Rod has suggested. If it's too much gain, you can halve it by putting a 10k in there instead of a 4k7, which is another thing I'm going to try. And in a last ditch effort, I'm going to insert my into the input socket and see if that makes a difference. I doubt it will. No, seriously, I'll remove or pull the 220 ohm resistor on the diode limiter circuit out of circuit to see if that improves the situation. I think it's a combination of not the correct op amps, or the circuit wasn't designed for these op amps, plus too much gain ahead of it. So those are the changes I'm going to try, but I'm going to do them tomorrow because I've been up since 1:30 this morning and I'm really tired, and I don't want to mess with electronics when I'm tired because I'm bound to mess it up. And I just double checked the value of those capacitors. They are definitely 104s or 100 nanofarads, so we're good there. Alright, well, I'll see you guys tomorrow or the next day, depending on when I get around to doing it. But for you, it'll be in the next few seconds. Good morning. It's way too early a clock. It's like 6:30 in the morning, so I have to be relatively quiet because people are still asleep. Now, I've changed the op amps. That's done. Got my transformer connected into the full bridge rectifier. Thanks, Maddie. And got my test equipment set up, so I just need to set this up on a tripod and we can begin testing. Alright, just plug it in now. Looks like we've still got the distortion there. Yeah, but at least I know the circuit's working with the two TLO72s in there. Okay. So, before I go any further, what I'm going to do is I'm going to directly inject the signal into the M1 position, which is the top end of the potentiometer, and make sure that at least the output buffer stage is working. Directly into, if I can, directly into the pot. Wow, ugh. That's very interesting. The pot is fully anti-clockwise. Yeah, that really does a lot. Okay. So now I've connected it between the junction of R13 and R14, which is pin 3 of U2. Just rotate the control. As we can see, the master control is still operating the same. It's just not functioning the way it should. Okay, so now I'm going to change R11's value in the second stage of that op amp there, which is the 4K7 to 10K. That resistor there. Okay, R11 is now changed. I'll just plug it back in. Still very touchy. So yeah, this circuit does not work as intended. Oops, my arm's in the way, hang on. Just adjusting the gain. See, it's either full off, full on. So I do not know what's going on with this stupid circuit. Okay, these two capacitors here near the op amps have been changed to the ceramic ones. Let's see if that makes a difference. It's worth a try. Try turning the control the right way. No, I've still got distortion and it's still not operating as it should. Right, I'm going to try the last ditch effort. Remove that 220 ohm resistor on the diode limiter and see if that fixes the problem. Alright, as you can see, R14 is removed. Plug it in. That distortion's still there. And the operation is exactly the same. So it has nothing to do with the diode limiter circuit. I really am at a loss as to what's going on here. Yeah, I just disconnected the input lead from the board. I'll plug it back in. Well, that is kind of interesting. The operation's a little bit different. Unplugged again. Control works a bit differently, but it still doesn't have much range. Temporarily lifted the input's ground connection. Now we've got square wave distortion. No, it's not making that much difference to the circuit. Okay, well, it was worth a try. So what do I think? Well, that master volume control is going to piss me off when using it due to its current operation, and I can't for the life of me figure out why it's doing what it's doing. That was a soldering iron. Maybe someone in the comments section there can shed some light. I've eliminated all possibilities. Op amps, the frequency bypass capacitors, high frequency bypass capacitors for the power supply lines to the op amps, the diode limiter, ground wiring, stuff like that. I can't even begin to fathom what's going on here, but that's just the way it is. I might reinstall the 220 ohm resistor because, well, it doesn't make any difference with it in or out. So yeah, I'm in the process of editing the video, and one thing did actually occur to me. Now, yes, I'm using handheld camera work, but the only other thing I can think of is the wiper is directly connected to the op amps input on the output buffer with a 100k ground reference resistor. How about we isolate the input from the pot by sticking a capacitor in series with it, say a 1 microfarad MKT capacitor, or even the same as what's on the output there, a 2.2 microfarad electrolytic, and see if that would make a difference. So that's sort of my thinking there, and that would directly isolate pin 5 of the U2B buffer stage from the pot, because I noticed that when I was injecting my frequency signal directly into the top of the pot here, the clockwise position, the operation was exactly the same, where it would be either full off or full on. That may be that resistor is affecting the pot because it's directly connected to its input pin, so we're causing a unusual load on the pot, and by rights, really, you should have a capacitor isolating the pot from the input of an amplifier stage, same as there should really be a capacitor here on the clockwise position isolating the output stage of that one before the pot. Technically speaking, it also keeps DC out of the pot, because over time the small DC offset output voltage that's present on all op amps is going to eventually make this control sound rather dirty, scratchy. So that's just food for thought there of my thinking, I guess, of it's the only other thing I can think of that would be affecting the circuit is the fact that this pot is directly connected between the output of this op amp stage and the input of this op amp stage. If it was isolated via a capacitor, maybe it'll work a little bit better, because don't forget, op amps do have a certain amount of micro voltage coming off their inputs. Ideal op amps should have no voltage or current flow on any of the inputs, and the op amp tries to make both inputs the same, but in reality there is a small leakage voltage on both of these pins of the inputs of all op amp stages. It's just the way it is. That's why you use blocking capacitors. So that's what I'm thinking. I don't have one. I'll have to go out and get one, so I'm not going to end the video just yet. This is going to be my last try. I'm going to put it in, and I'm just going to leave it in there even if it doesn't make a difference. And I'm going to wire it off the back of the pot. So that'll be my next, well, test, I suppose, for a better word. Okay, a short time later, well actually 8 or 9 hours later, I've got the capacitor. It's a 2.2 microfarad 63 volt. The positive lead of the capacitor is soldered to the center connection of the pot. There's a little bit of heat shrink here with the original center lead wire, which is the yellow one disappearing up here, just soldered there and then protected with the heat shrink just so it doesn't accidentally short on anything. And later on that can be hot glued to the back of the pot there to stop it from moving around if so need be. But I've got to pull all these controls off again anyway to do the labeling on the front, so I'm going to leave it as it is for now. And now I need to get all the test equipment back on the desk and the power supply and test again. Alright, got all that set up. This is, yeah, okay. Right, so we'll focus now on the oscilloscope and I'll plug it in. I've lost my active wire out of the plug. Shove that back in there. Still nothing. Okay, help me to understand what is going on.
As you can clearly see, I have no regards for safety.
Honestly, that Coke bottle's in my way. I honestly don't know why this is refusing to work. It should do. Okay. Now my extension cord's still plugged in, is it not? Well, it should be. Why are you being a pain? Oh, this is a complete fail. What have I done here? I have absolutely no idea at this point. Yay, finally got it to work. Look at me. Alright, so let's just test the operation now. Well, it looks like it is actually working a heck of a lot better. Whoops. Let me just turn that gain right down. Okay, let's try that. It's still not quite good, but we no longer have that distortion when the volume control is fully anti-clockwise. I think I have just won. Yay, I am so happy. Put that on the maximum sensitivity and I'll see how much actually comes out of this now. We're winding the control up. Whoa. So the actual maximum output voltage swing that I'm getting is around about 3.4 volt peak to peak before clipping. That's with the master control wound full up and the gain control about halfway just before the clipping diodes come into play. And yes, I have soldered them back in. Well, soldered the resistor back in. So now that I know that's working, and that when I rotate the master volume control we do get somewhat control over it. It's still very touchy at the bottom end, but at least it's better, and that the annoying distortion is gone. Yes, you do need to have a capacitor in series with the center wiper of the volume control pot and the input of the op amp. So my theory was correct of putting a capacitor there. I've put 1 microfarad, but it's 2.2. It's the same as the output one. It's really much of a muchness. But the positive going towards the wiper. Yeah. And that seems to remove whatever loading the input pin of this particular section of the IC was doing to the pot. And it's also isolating that resistor from the pot as well. So, I guess the next thing to do to finalise this video and finish it off is to pack some test equipment away, set the computer back up and do a final sound test. I am at the stage of elation, so I am very happy. Was that even the correct word, elation? I'm elated anyway. So, okay, I'll get that done and we'll set up for a sound test. Okay, so let's test this out. Now, I can hear it, apart from the noise. If you can hear it, that control is now working smoothly. So, I'm pretty happy about that. Turn that gain up a bit. Okay, let me turn the master down. Yeah, you do get a bit of leakage, but that's alright. Alright. Cool. Cool. Alright, so that seems to be functioning as it should. I might try the electric guitar now just for completeness. Okay, yeah, it still distorts, so that's fine. Do the forbidden riff! About all I can play of that. Well, it's not that that's all I can play of that, but that's all I can play of that on YouTube due to copyright. So, I don't want to get a copyright strike. Right, so in conclusion, I've fixed the problem. I'm happy. And you definitely do need to put a capacitor in series with that volume controls wiper or the center lead before the rest of the circuit, or else you're going to end up with the problems I did. I think Rod Elliott did mention in his text somewhere that you should really consider putting a capacitor between the master volume control and the rest of the circuitry to prevent DC going into it, but I have to reread it. because I was going to email him and tell him my findings with his current layout, that he may want to consider changing the circuit board for a revision C, or whatever it is now. Yeah, revision B at the moment, so revision C, and add an extra capacitor on the output of the potentiometer before the output buffer's input. Or else, yeah, you get some nasty distortion at the bottom end, or fully anti-clockwise position, and the control is very touchy. Now it seems to be functioning a lot better than it was, so I am happy. Anyway, I want you to be happy, and go down there below and comment and rate and subscribe if you haven't already. And if you want to become a Patreon, you can simply click the link in the description, and you can pay as little as $1 a month, or pledge as little as $1 a month, I should say. And you can always follow me on Facebook. That link is also in the description as usual. Anyway, this is the Astro 30 saying, I am so elated. Happy days. It's currently Australia Day today when I finish this video, so happy Australia Day. And just, yeah, have a great day. Alright, the Astro 30 saying, see ya, bye.